Hello students, in this video I will discuss the chapters of sequences, in which I will discuss the Cauchy's general principle for convergence, and which is the syllabus of mathematics paper 1 in BSc 4th semester, Karnataka University, Dharwad. So now I will see the statement of Cauchy's general principle of convergence. So let us see the statement. A sequence is convergent if and only it is a Cauchy sequence. Now we shall consider that. Let us consider here An is a Cauchy convergent sequence. Next we need to prove that which is a Cauchy sequence. So we assume that sequence is Cauchy convergent sequence which converges to a limit L. And in order to prove that a sequence An is a Cauchy sequence, let us take a definition of convergent sequence. So let epsilon greater than 0 be given. Then there exists a positive integer m such that this sequence An converges to L that as limit n approaches to infinity, or else modulus of An minus L less than epsilon by 2 for all n should be greater than or equal to m. Just we called it as equation 1. And you can you can choose for n equal to m, we have there am minus L that should be less than epsilon by 2. Just we called it as equation 2 there. And then we can consider the difference between magnitude of An minus Am. That means modulus of An minus Am. Just you can add and subtract by L here and take a grouping the terms like An minus L and Am minus L in that modulus. And if you take individual modulus, that equality becomes inequality. So that is modulus of An minus L plus Am minus L. So that as we have defined there, modulus of An minus L which converges to L for that sequence An, and sequence Am converges to L, that is for there. And if you take as we have already defined there, so that epsilon by 2 that is so then it means what? Modulus of An minus Am is less than epsilon for all n should be greater than or equal to m. That we conclude that, which is the definition of Cauchy sequence, so that this sequence An is a Cauchy sequence. Now let us prove in converse part. So let us assume that sequence An be a Cauchy sequence, so that we need to prove it here that sequence An is a convergent sequence. So since sequence An is Cauchy sequence and every Cauchy sequence is a bounded, that means sequence An is a bounded. So since every bounded sequence has a limit, limit point, we can say that L. Since L is a limit point of sequence An, and every neighborhood of that limit point L which contains infinitely many terms of that sequence An, that implies sequence is that An, nth term of sequence An, is member of that L minus epsilon and L plus epsilon by 3. This means An belongs to L minus epsilon by 3, comma L plus epsilon by 3 for infinitely many values of n. And now in particular we can find an integer small k greater than m such that this ak is again that instead of n replaced by k there, so that it is ak belongs to L minus epsilon by 3, comma L plus epsilon by 3. That means ak is all this ak converges to L. So that means modulus of ak minus L less than epsilon by 3 we call that as equation 3. And also since k is greater than m and sequence an is a Cauchy sequence, now let us take a definition of Cauchy's. So for given epsilon greater than 0, there exists a positive integer m such that modulus of an minus am should be less than epsilon by 3 for all n should be greater than or equal to m. Let you call that as equation 4. But k is greater than m. Therefore, from equation 4, we are going to replace that an replaced by ak. So that is ak minus modulus of ak minus am should be less than epsilon by 3. Let you call that as equation 5. Now we can see that is sequence converges to L. We wanted to prove that. So that we need to take that is modulus of an minus L. So in that terms, just we can add and subtract by the terms am and ak. So that means equal to modulus of an minus am plus am minus ak plus ak and minus l. And just clubbing the terms looks like that. Here modulus of an minus am, am minus ak minus l. So that is, it is as we know that if you take individual magnitude, this equality becomes inequality, and then this modulus of an minus am is epsilon by 3, and modulus of ak minus am is also epsilon by 3 by the equation 4 as we have discussed in previous slides. And also we have this ak, particularly this sequence ak is also converges to L. That also magnitude of ak minus L is also epsilon by 3 by the equation 5. So that ultimately this modulus of an minus L should be less than epsilon for all n is greater than or equal to m. This means what? After n and equal to n, this nature of this sequence is converges to a limit L. Means the sequence an converges to L. So thus we conclude that a sequence is convergent if and only if it is a Cauchy sequence. So we have discussed in this video statement and proof of Cauchy's general principle of convergence. So these are the references we have followed in this lecture. So these are the important books. You can refer also that. Thank you.